In the last class, we discussed the definition of valency. It is the combining capacity of an element. That means how much an atom can bond with another atom. That means how many electrons can be given or taken or even share. Yes, number of electrons gain, loss or share so as to make the octet of the electron in the outermost shell. Then, whenever an atom of an element containing 8 electrons in the valence shell, this is the most stable arrangement for any atom. Whenever an atom of element containing 8 electrons in the valence shell, this is the most stable arrangement for any atom, except helium, which means except helium has 2 electrons in the valence shell and is also known as duplet structure. This is the most stable structure of helium, except that which have 8 electrons in the valence shell, that is the most stable arrangement for any element. This arrangement is known as octet. Okay, did you catch what is octet? And most stable arrangement for an element. That means the most stable arrangement shown by the element which are known as noble gases. So as the noble gases except helium, helium shows a duplet structure. All the noble gases have an octet structure, and that is why noble gases are also known as inert gases. Here helium, neon, argon, krypton, xenon, radon are noble gas elements. Okay, it has most stable structure, so they do not react with any other substances. They do not undergo any chemical reaction. That is why they are also known as inert gases. So whenever an element it has 8 electrons in the valence shell, that is the most stable arrangement for any element. So all the elements try to achieve this noble gas configuration. Let's see how they do that. Here the table shown. So whenever an element has 1, 2 or 3 valence electron, it can lose electron. So when an element loses 1, 2 or 3 electron, such elements are known as metals. Metals are those elements which can lose electrons. Similarly, whenever there are 5, 6 or 7 valence electron, in order to complete the octet, they can lose 5, 6 or 7 electrons. But what is the problem? It is not easy to lose these. Instead, they gain 1, 2 or 3 electrons. So such elements which gain electron to complete the octet, here they are known as non-metals. And when the element have 4 valence electron, it is not easy to lose or gain 4 electrons. We know that. So instead it shares 4 electron with some other atom. Such elements having 4 valence electron are known as metalloids. So all elements try to achieve the nearest noble gas configuration. Okay. Next, here they are showing if we have sodium, it has 11 electrons. So it has the electronic configuration 281. So in order to complete the octet, it has to lose 1 electron. So now it becomes Na plus. This is because if it lost 1 electron, now it has 1 electron less. So it becomes a positive ion. It loses 1 electron and becomes a positive ion. That means the electronic configuration is 2, 8. Now the valence shell has 8 electrons. So it is stable. So sodium loses 1 electron to have a stable electronic configuration. So sodium is a metal. Next, here chlorine. Chlorine, it has an electronic configuration 287. Now in order to complete the octet, it gains 1 electron. It needs 8 electrons in the valence shell. So in order to complete the octet, it gains 1 electron. The atomic number is 17. So 2, 8, 7 is the electronic configuration. Now in order to complete the octet, it gains 1 electron. It needs 8 electrons in the valence shell. So in order to complete the octet, it gains 1 electron. So when it gains 1 electron, it becomes Cl minus. As there is 1 extra electron now, it becomes negative ion, having an electronic configuration 288. So now there are 8 electrons in the valence shell, so it is stable. And the chlorine gains 1 electron to satisfy the octet. Chlorine. So chlorine is a non-metal. Next, what happens when an element has 4 valence electron? So now carbon has 4 valence electron. It is not easy for carbon to lose or gain 4 electrons. So it shares 4 electrons with the 4 hydrogen atom. Let's see how it does that. So now each hydrogen atom shares 1 electron each with the carbon atom. In doing so, each hydrogen has 2 electrons. That is, each hydrogen atom has a duplet structure and carbon has 6. So now carbon has 8 electrons. So when it satisfies the octet rule, so both the carbon and all the hydrogen atoms are now stable. So in the case of carbon or elements having 4 valence electrons, they become stable by sharing electrons. Such elements are metalloids. Here 4 electrons and 4 hydrogen electron, 4 carbon electrons and 4 hydrogen electron, they share each other to form complete octet. Next is, what is valency? We already discussed that the number of electrons gained, lost or shared so as to make the octet of electrons in the outermost shell. So let's see, when an element has 1 valence electron, it can lose 1 valence electron. So it have valency plus 1, or we can simply write 1. When there are 2 valence electron, it can lose 2 electrons to complete the octet. The valency becomes plus 2 or simply 2. Similarly, for 3 we get or simply 3. Now when there are 5, 6 or 7 valence electron, in order to complete the octet, it gains 3, 2 and 1 electron respectively. And when there are 4 valence electron, these elements are metalloids, they share 4 electrons, so their valency is 4. For that, the valencies of the elements having valence electron from 1 to 7. Okay. Next we move to the next topic, variable valency. Now some elements, they lose electrons from both the outermost shell. The outermost shell is known as ultimate shell or valence shell, and the shell before the outermost shell is known as penultimate shell. From the figure we can see that ultimate shell and penultimate shell. Ultimate shell means the outermost shell and is also known as valence shell, and the shell before the ultimate shell is called a penultimate shell. Some elements, some exceptional elements, they can lose electron from both the ultimate shell and the penultimate shell. Certain elements so exhibit more than one valency that they show variable valency. When they do that, they can exhibit more than one valency, so they are said to exhibit variable valency. So far we have studied that the elements lose electron from the ultimate shell, so they lose electron from penultimate shell also. So beyond the scope of this lecture, you can study it in higher class. Some elements, some special elements, they lose electron from both the ultimate shell and the penultimate shell. Let's see some examples. Copper shows 2 valencies, that is plus 1 and plus 2. Copper showing 1 and 2, that means they can lose electrons from ultimate shell and penultimate shell. Copper lost 1 electron showing plus 1 valency, and copper lost 2 electron in sometimes showing plus 2 valency. Similarly, in the case of iron, they are showing loss of 2 electrons and 3 electrons. Tin showing 2 and 4 valency. Okay, they can exist 2 oxidation state. The valence is also represented by oxidation state, copper 1, copper 2. 1 oxidation copper 1, 2 oxidation, and iron 2, iron 3. Next, formula of compounds. Here the copper 1 2 valency, iron 2 3 valency, showing tin 2 4, lead 2 4. These are variable valencies. Next, formula of compound. Write the valencies of radical at the top of the symbol. Firstly, you should write the valencies of each radical at the top of the symbol. Here I am showing that. Firstly, you should write the valencies of each radical at the top of the symbol. A, Y, B, X. Y is the valency of A and B is the X is the valency of B. Second, divide the valency. Here A raised to 4, B square. Here divide the valency of each radical by a common factor. Here the common factor is 2, and then cross the valencies of the two radicals and place the numbers at the lower side of the radical as subscript. In the case of a compound radical, enclose it in with a bracket and place the number outside the bracket. For writing the symbol of the two radicals, write the positive radical to the left and negative radical to the right. That means first writing the symbol of the two radicals, write the positive radical to the left and negative radical